Welcome back to Math 151. Last time we started discussing logarithmic differentiation, and we saw that the derivative of the function x to the x is ln x plus 1, all multiplied by x to the x. This is not a fact that you need to memorize, it's just the first example of how to use our method. So, what is this method? In general, our method for finding the derivative of f has 3 steps. In step 1, we use that same idea from last time, which is to compute ln of fx. It's essential at this stage that you simplify ln of fx using whatever log rules you need to. In the last video, we simplified the ln of x to the x to get x ln x. And that was really important when we were computing the derivative. It's the simplifying part. In step 2, that's when the derivative came. We compute the derivative of ln fx. And the derivative of ln fx always gives us f prime of f divided by f of x. That's what we're always going to have on the left side at the end of step 2, but what we have on the right side depends on f. And then finally in step 3, we're going to multiply. We always multiply by the original function f of x, because that clears out our denominator. We isolate f prime. And since f prime is what we were looking for in the first place, we're done. Let's see this method in action on a really different kind of example. Here's a function. fx is sine x raised to the 7th. That 7 is outside the function sign, times e to the x, divided by x squared plus 1. Notice that this is something that you could differentiate using all the derivative rules we already have. You could see this as a quotient, and then when applying the quotient rule, you'd need to differentiate what's on top, which is a product. That means you'd need the product rule. But to use the product rule, you'd have to differentiate each factor. So you'd have to use the power rule and the chain rule on the left, and you'd have to know what the derivative of e to the x is on the right. So you can do this right now, no logarithmic differentiation, but it's really hard. So let's see what it's like to use logarithmic differentiation instead. Step 1 is the step where you take the natural log and where you simplify using log rules. We don't want to have the natural log of this big quotient. We want to have natural logs of nice simple pieces that we're combining with pluses and minuses. That's what the log rules can give us. Pause the video for a moment and try to simplify the natural log of this function as much as you can. Are you ready? This is what you should have gotten. 7 times the natural log of sine x plus the natural log of e to the x, which is just x, and then minus the natural log of the denominator, x squared plus 1. If you need a little reviewer about log rules, that's okay. We're going to talk about them in depth in the next video. We're ready to move on to step 2. Step 2 is the step where we actually take the derivative. On the left-hand side, we always get f prime of x divided by f of x. That's just what the chain rule gives. The right-hand side, in this case, we're going to do term by term. The first term here, 7 ln sine x. When we use the chain rule, it says differentiate ln. Well, that just puts whatever's inside ln in the bottom. But then you have to multiply by the derivative of the inside, which in this case is cosine. And we can't forget about this constant of 7 out in front. The derivative of x is just 1. And again, for the natural log of x squared plus 1, we're going to use the chain rule, and we'll get 2x over x squared plus 1. So we're ready to move on to step 3. And in step 3, all we do is multiply by f of x. So we get f prime of x equals whatever we had in the last step. I'm just copying it verbatim. And that whole thing in parentheses has to be multiplied by our original function. This big thing, sine of x, all raised to the 7th, times e to the x, divided by x squared plus 1. Now you could simplify this expression, say by distributing, and make some cancellations, but you don't have to. There's a perfectly good answer to the question, what's the derivative of f? Depending on the actual problem that you're given, you might want to simplify it. If you're just asked to find the derivative, this is where you should stop. But if you're using the derivative to do something else, like to compute a tangent line, or you're going to compute the second derivative, then you might want to do some algebra. What I skipped is really the hardest step. Call it step 0, which is to decide if you want to use logarithmic differentiation at all, right? A problem's usually not going to say, use logarithmic differentiation. It's going to say, here's a function, differentiate it. And you have to decide what to do. Please go on to the next video for a discussion of step 0 and for more examples.